All right, so get this. Ever wish you could just like walk into a virtual world? Like straight out of Ready Player One. I know I have.
Yeah.
Today's deep dive, all about making that dream a reality, but with hopefully way less clunky equipment.
Yeah.
And hopefully without the dystopian future, right?
Right.
You wanted the lowdown on the latest in VR navigation, and let me tell you, this research paper kind of blew my mind.
Yeah.
It turns out the key to making VR movement feel more natural, more immersive, might be right under our noses or at the end of our arms.
That's right. We're talking about a system called ArmSwingVR.
Okay.
And it leverages something we do every day without even thinking swinging our arms while we walk.
Okay, I know you're thinking arm swinging, really.
Yeah.
But trust me, this is way more groundbreaking than it sounds. The research paper lays out some serious limitations with current VR navigation methods.
Yep.
And we're talking about those awkward walking-in-place setups
Yeah.
that leave you feeling like you're running a marathon in a phone booth.
And don't forget the notorious VR nausea.
Oh, tell me about it.
One of the biggest hurdles for developers is figuring out how to minimize those feelings of dizziness, disorientation. It plagues so many VR users.
Exactly. And that's where ArmSwingVR comes in. This isn't just about making VR movement feel more natural. It's about addressing a really crucial comfort issue.
Right.
But before we get ahead of ourselves, let's break down how this whole thing actually works.
Okay.
No fancy treadmills or motion capture suits needed here, Rick.
You got it. All you need is a standard VR headset and controllers that track hand position,
Right.
which a lot of systems already have.
Yeah.
The real magic is in the software. ArmSwingVR uses an algorithm, and yes, we'll get into how that works in a bit,
Okay.
to translate your arm swing motions into directional movement within the virtual environment.
So no more fumbling with joystick controls or teleporting around like a glitching video game character.
Right.
It's just you walking through a virtual world.
Yeah.
Just by swinging your arms like you normally would. It almost sounds too good to be true.
The research team wanted to make sure it wasn't.
Okay.
So they put ArmSwingVR to the test with a user study.
Perfect. Let's dive into that study because I'm dying to know, did it actually work?
It did, and this wasn't just like some quick demo either. They had 18 people, a good mix of ages and genders, try out both ArmSwingVR and a traditional walking-in-place method for a full 15 minutes each.
Okay, so long enough to get a real feel for it. But were they just like wandering around, or did the researchers have them actually do stuff in VR?
Oh, they had tasks to complete. Navigating courses, picking up objects, placing them in baskets, sort of a virtual obstacle course.
Makes sense.
Which is actually pretty standard for this type of research. And here's the kicker, there was no significant difference in performance between the two methods.
So ArmSwingVR wasn't any harder to use, even though it's based on this whole new way of moving in VR?
Yeah.
That's impressive. But let's be real, what about the nausea? That's the make or break for me with a lot of VR experiences.
I hear you, and the study actually found something pretty remarkable on that front. People using ArmSwingVR experience significantly less nausea and simulator sickness compared to the traditional method.
Whoa, hold on. So not only does it feel more natural, but it might actually help with VR sickness.
Right.
That's huge.
Right.
I mean, think about the possibilities here. This could be a game changer for people who've had to avoid VR because of motion sickness.
Absolutely. And it gets even better. Remember how we talked about the importance of presence and immersion in VR?
Yeah, how real it actually feels to be inside that virtual world.
Exactly. And the study found that both methods, ArmSwingVR and walking in place, received comparable ratings for presence and immersion.
So even though it seems like a simpler approach, you're not sacrificing that sense of really being present in the VR environment. You're telling me I can have my cake and eat it too. This is too good to be true.
Well, there's one more cherry on top. The researchers also looked at participants' heart rates and their perceived exertion levels, basically how much effort they felt they were putting in. And, you guessed it,
ArmSwingVR.
ArmSwingVR came out on top again.
No way, really. Less physically demanding than walking in place.
Significantly less, according to the study. Lower heart rate increases, lower perceived exertion.
Wow.
So not only are you feeling less sick, you're actually exerting yourself less, too.
Okay, my mind is officially blown. This feels like such a simple yet elegant solution to some of the biggest challenges in VR right now.
And that's what makes this research so compelling. It highlights the potential of tapping into natural human movements to create more intuitive and immersive VR experiences.
Okay, but let's talk about the elephant in the room. Arm swinging makes sense for walking, but what about all the other actions you might want to do in VR? Jumping, crouching, grabbing objects. How does ArmSwingVR handle those? That's the question, right? Like, am I going to have to do some kind of ridiculous flailing arm dance to pick something up off the virtual floor?
Well, for now, ArmSwingVR is primarily focused on locomotion, that smooth, natural walking experience.
Okay.
The researchers acknowledge there are limitations when it comes to those other actions.
Okay, so maybe not the be-all, end-all solution just yet. But it sounds like a fantastic stepping stone. Did the researchers offer any hints about where this technology might go next?
They did highlight this as an exciting avenue for future research. What's fascinating is that our bodies have so much more information to offer subtle shifts in weight, leg movements, even our posture.
Oh, interesting.
Imagine if VR systems could tap into all of that.
Now we're talking full-body immersion. That gets into some seriously futuristic territory.
It does, but it's not as far-fetched as it sounds. There are already experiments with things like haptic feedback suits and even specialized footwear that can simulate different textures.
Wait, hold up. VR shoes. Tell me more about these shoes.
It's pretty wild. Imagine feeling the gravel crunching under your feet as you walk through a virtual forest, or the smooth chill of marble tiles in a grand hall.
Okay, that's next-level immersion. You could practically trick your brain into thinking you've been transported to another world.
Exactly. It all comes back to that mind-body connection. The more closely we can align our physical experience with the virtual environment, the more real it feels.
This whole conversation has really changed my perspective on VR. It's not just about fancy graphics and processing power. It's about understanding and utilizing the incredible sensory machine that is the human body.
It's about bridging that gap between the physical and digital worlds. And as we continue to explore the possibilities of VR, who knows what other aspects of our own physicality we might unlock.
It's like stepping into the unknown, both literally and figuratively. So, to bring it back to our listener today who specifically requested this deep dive, what's the big takeaway here?
I think the biggest takeaway is that the future of VR is all about creating experiences that feel incredibly real, not just to our eyes, but to our entire body.
And it all starts with a simple, natural movement, the swing of an arm.
A movement so familiar, we often take it for granted. Yet, as this research so brilliantly demonstrates, it holds the potential to revolutionize the way we interact with virtual worlds.
It makes you wonder what other seemingly ordinary human movements might hold the key to unlocking even deeper levels of VR immersion. But I think that's a question for another deep dive. Thanks for joining us for this fascinating exploration. We'll leave you to ponder the possibilities, and who knows, maybe this will spark an idea that changes the future of VR forever.